Hello students, welcome to lecture of Kinematics and Theory of Machine. Myself Professor Patel, and we are going to continue our chapter Velocity in Mechanism, and in this lecture we will study the example based on relative velocity method. Okay, let's start. Before starting the example of velocity in mechanism, we will revise some points we have learned in a previous lecture, because in this chapter there is no derivation or any formula. Totally example depends on the fundamental things we have learned in theories. Okay, so you know that first of all, first rule is that all fixed point will be at origin. So in example, in mechanism, whatever the points, number of points you see the which are fixed will be at the same point on a origin point. Okay, or in a velocity diagram. Second is the velocity of any link, any point on a link will be perpendicular to link. Third is the direction of slider always be the line of action passed through the origin point in a velocity diagram. I am going to explain you this again, because if the piston is moving in this direction, then you will draw the line passing through the origin. Okay, I'm giving you another example. If the slider is sliding some at position, some at angle is there, and it is sliding with this direction, so what you have to do in velocity diagram, you have to draw the line passing through the origin in direction of line of action of piston. Now you can understand that what is rule number 3. Direction of slider will be same as line of action. Its direction will be in this line, but it will pass through the origin point. Okay, and after that, last and fourth rule is the velocity of any point on a link. Means in for the velocity, if on a link you want to find the velocity of any point, you have to take this ratio between the space diagram and velocity diagram. Okay, let's start the first example of velocity in mechanism. So you can see here in a 4-bar chain mechanism, ABCD, AD is a fixed, so I can draw the AD here, and then its length is 150. Okay, the crank is a 40, crank here it is a 40, and rotate at a 120 rpm, and link CD. Okay, AD, and there is a link CD directly given here. Okay, and oscillate about the D point is here, and BC and AD are equal length. Okay, so this fourth link and this first link is a same length. Find the angular velocity of CD. Means we have to find the velocity of link CD. Angle of BAD is given. So first of all, we have to draw this whole mechanism. So check this dimension first. So length of all 4 links given here. Okay, so first of all we have to draw this space diagram. Minimum 1 or 2 marks are given in an exam for drawing only the space diagram which is given in a paper. So we have to just draw the given figure with a scale. Okay, so we can see the 4 dimensions of the link. AB is equal to 40, CD is equal to 80, and AD is equal to 150. So how we can draw this in our drawing sheet? So first of all, we have to consider the largest and smallest dimension. Largest is 150 and smallest is 40. So 150 means half foot or 15 centimeter. So we have to descale the dimension so we can draw easily. So we will take the scale is equal to 1 mm is equal to means 1 centimeter in our drawing will be in actual will be 2 centimeter. Okay, so AB is equal to 40, but in our drawing it will be 20 mm only, and largest dimension which is 150 mm will be in our drawing sheet, it will be 75 mm only. Okay, so we will draw this displacement diagram. How we can draw this displacement diagram? First of all, start with the AD, which is a fix.
So AD is equal to 150, but in our drawing sheet it will be 75 mm. Now what is given? The angle between BAD is given. What is the angle given? 60. So we will take the 60 degree here. So 60 degree line, but how much it will be the length of, this is the AD. AD. Now A to B, length is given 40 mm, but in our drawing, it will be only 2 centimeter. Like this. This is the 60 degree angle, and this length AB is a 2 centimeter. Okay, now CD is given, CD length is given 80 mm. So in our drawing it will be 40 mm, and other dimension BC is given is equal to AD, means it will be 75. So how you can draw these B to C and C to D? Okay, but CD is given 80 mm. So how you can locate the C point? So as you know that distance from B to C is given 150. Okay, so I will take here dimension 75. B to C 75, and I will take one arc here. Okay, simple arc. Then from D to C, CD distance is given 80 mm. So my dimension will be here 40 mm here, 40, and I will draw the arc, second arc here, and the intersecting point between these two arcs, it will be the C point, and I will draw here this line like C to D and B to C. So that's how you will draw the A, B, C, D. A, B, C, D. Okay. Now this is the space diagram, and using this space diagram, we will draw the velocity diagram. Okay, so as you can see on the screen, this is the space diagram. We have drawn this A to B, B to C, C to D, and D to A. Now, first of all, remember that to draw the velocity diagram, we must need one velocity of any link, and for that, they always give the RPM or angular velocity. If they give the n RPM, so we will find the omega. Omega is equal to 2 pi n by 60. And from using omega, we can find the velocity of that link. Velocity is equal to angular velocity omega into length of that link. In this example, velocity of B with respect to A is given, which is a 120 RPM. So we can find the omega. Omega is equal to 2 pi n by 60. So we can find the angular velocity of point B with respect to A, which is a 12.56 radian per second. Okay. Now, how you will find the velocity of B, linear velocity V with respect to A. Linear velocity of B with respect to A will be angular velocity omega BA into length of that AB link. But remember that length of this AB link is 40 mm. Okay, in actual dimension, not we have drawn here only 20 mm in our drawing. Okay, this is the scale we have taken. So don't measure in a drawing. Actual dimension is the 40 mm. We have converted that into meter because linear velocity meter per second. So angular velocity into length of that AB link in a meter 0.04. So we will find the velocity, which value is a 0.503. So this is the velocity of B with respect to A. Now we will draw this velocity in our velocity diagram, and using this velocity we will find the all other velocities of links. Okay. So first of all, to draw the velocity diagram, we need the scale for the velocity diagram. And which scale we will take? Think about that. How you can draw this 0.5 meter per second? So first of all, we have to take some scale. So I can say that 1 meter per second is equal to something 100 mm. Okay, this scale I have decided, which is a 1 meter per second is equal to 100 mm. So what will happen here? 0.503 meter per second. So we have to just multiply to 100 and we can find this AB vector or velocity of B with respect to a vector 53 mm, which is a very easy to draw. So let's start to draw the velocity diagram for this mechanism. So rule number 1, all should remember the rule number 1, all the fixed point in a space diagram should be at the origin point in a velocity diagram. So how you will draw the velocity diagram? So first of all, take one point which is the origin point or reference point for the all other links. So you can see here A and D, these both points are fixed. So in a small A and D, these 2 points will be at the same origin point because both points have a velocity 0. How many number of links or element which have a 0 velocity will be on a same point in a velocity diagram? Now with respect to A, velocity of B. So remember that velocity of any point on a link will be perpendicular to link. Perpendicular to link. But in which direction is depend upon the direction of the link. In this example they have given this is the direction in a clockwise direction. So velocity of B with respect to A will be perpendicular to link and direction will be this. In this direction. So perpendicular to link I have to draw this here and length will be, which we have found it, AB is equal to 50.3 mm in this direction. So how you can draw this perpendicular from AB link here? So there are multiple methods are there and using that method we can draw the perpendicular here from AB. So first easiest method is that using the set square. Using 2 set square you can find the perpendicular at any link. So first of all check this. First of all I have to set the set square here which is parallel to link, and then using second set square I will attach here. This is the perpendicular to this link. So I will set here which and line which is passing through this. So check this like this. And this line is a perpendicular to AB and length will be this is the AB vector velocity of B with respect to A. Okay, this is the AB. Okay, so using this method you can find perpendicular at any position. Second method is using the ruler. How you can draw the perpendicular using the ruler? So simple method is that for that first of all you have to draw the perpendicular on a link very lightly, like here you have to draw the perpendicular very lightly here. So you can see here this is the perpendicular I have drawn here, like assume that this is the rollers. So using this roller perpendicular you can roll that on any place and you can draw the perpendicular. Okay, but set square is the easiest method. Now we have the B point. So from A, B, C, D we have finded the A, D and B. Now we need the C point. And how you can find the C point in a velocity diagram? Easiest method is that C is moving with respect to B and also C is moving with respect to D also. But we don't know the magnitude, but we know the direction. Okay, when we consider this BC link, the velocity of C with respect to B, the direction of C will be perpendicular to this link, maybe perpendicular in this direction or maybe in this direction. Perpendicular to link means above or below. We don't know the direction right now, but means on a which side we don't know, but we know the direction will be always perpendicular to link. So we will draw this perpendicular from this B point. We don't know the magnitude, so we don't know the length of that link, length of that line, but we know the direction. So we will draw here like this, perpendicular to this BC link. So we will put the set square here on BC, and then using this set square, now we are talking about the C with respect to B. Okay, so we will put the set square on BC link, and using the set square we will draw the line from the B, like here, B. Okay? And this line, we will draw this line, but very lightly, very light line will be there, because this is not the final length. Okay, we know the direction, C point will be on this line, anywhere that can be possible. But now this C point is also with respect to D moving, because C point is also on this CD link. So C with respect to D. So now we have to draw this perpendicular from this CD link, and from which point? This D point. So velocity of C with respect to D, so I will put here the set square here like this, second here, and this perpendicular we will draw from the D point, like this. Okay? So you can see this, when these two lines will be intersect, the point you will get will be the C point, and you can dark this line also. This is the velocity diagram. This triangle is a velocity diagram, and extra line you can erase. Okay, so this is the velocity diagram, and how you can draw this I will explain you again. First of all, one line you can draw easily, because always they give the velocity. Okay, then for the other link you have to just draw the perpendicular to link, all the link. For all other link you have to draw the perpendicular to link, and you will get here. Now using this, how you will find the angular velocity of CD link? Angular velocity of CD link. So angular velocity of CD. First of all, you know the velocity of CD is equal to angular velocity of CD into length of CD length. Now you can find the omega CD using velocity of CD divided by CD. So for finding the angular velocity of CD, you need the velocity, linear velocity. And how you can find the linear velocity of CD? CD indicating the velocity of CD, Okay, so measure this CD distance here. We will measure the CD distance is a 38.5. Okay, but we have taken the scale here, which is a 1 meter. 1 meter per second is equal to 100 mm. So now we have to divide this value by this 100, and you will get the velocity, which is the point velocity of CD is equal to 0.385 meter per second. And meter per second divided by length of that link. Okay, so length CD is 80 mm, but divided by 1000 you will get the 0.080. So omega CD is equal to, you will find the value 4.8 radian per second.